Well, in this video, I'm going to discuss about the Terraform modules. Why exactly we do need the modules and what is the necessary for that. First of all, before discussing about those all things, we need to know about two type of architecture. First one is a microservice architecture and second one is a monolithic architecture. What exactly is a microservice? See, first of all, when you are building any software, normally when the whole of the responsibility is on us, we tend to build the software in a singular format, like everything. For example, our front end code is in only one folder, backend is also in one folder, database related things are also in one folder, and everything is in a single format. And because you are taking responsibility of whole code, you know from end to end what all things are happening. Means if there are any errors or bugs, you could able to track those. But when you are building anything at a scale, at a huge scale, let's take example of an organization. In such case, taking responsibilities and ownership is become very tedious task, because you are dealing with a lot of code. For example, over here we have you know different types of servers, and over here we have two servers dedicated for front end and back end. In the front end we are writing everything that is related to front end, in the back end we are writing everything that is related to the back end. And in the second section we have the databases and the API, and we are writing everything related to database and API in these two servers. This is called as a microservice. We are dividing every services, and this is representation of a very small startup that started now itself. But at a large scale, at an organization scale, this front end is also divided into a lot of modules, a lot of singular structures. For example, in the front end also, you have the login page, you have the registration, and you have the dashboard, you have the home page, you have the payment section. You are having a lot of things. Those things are further divided in the front end when you go in the larger organization. Okay. This is the monolithic architecture. What exactly is a monolithic architecture? you know as I already discussed, when you are building anything at very low scale, like you are the only one, or you are having only three developers who are building whole of the software. In such thing, you tend to build the things in the monolithic architecture, like everything is in one folder, like front end, back end, database, everything in the one folder. Let's consider you have written a lot of a code because your startup is uh, it built five years back, and you have written a lot of a code. Now you hire some intern. When the intern comes and watches your whole of the project structure, he become panic, because there are millions of code. And for you and your developers, it is easy to find bugs and take ownership and maintain the whole code and test your whole code with unit test and integration testing. These all things, it is easy for you guys because you have built it from scratch. But when you're dealing with a new intern or a new guy, it becomes very difficult for him to read each and every part of the code and understand. The thing is that, in fact, if he writes any sort of a code and there are bugs and issues in that particular code, then it is become difficult for us to find those things, because we never introduce with a third person and his style of coding. And therefore, whenever we find the bugs, it is difficult for us to find those things, because we don't know where that particular issue is coming. We have to go through whole of the code to debug those things. Therefore, debugging is become one issue. And ages, like every day a new package is introduced. For example, let's consider there is some package where it uses SMTP protocol, the simple mail transfer protocol, to send messages. And SMTP, there is some module package that is developed in the Python which you are using in your project, and it is expired. Now you need to update those things. It become tedious task, because when you update that, you don't know where all you have used this SMTP protocol, because your architecture is combined one. You cannot able to find out where exactly I use these all the modules and where the update is required. And after that, this is also a problem. This is termed as aging, because you use a lot of things that will expire on one day. It is difficult for you to find those things. And ownership, if someone has made some changes and you don't know who made those changes, and you don't know where we are getting some issue, but we don't know where we are getting those issue. In such case also, finding ownership become difficult. Debugging, aging, finding the ownership, and maintaining the code is too huge. You are integrating a lot of test cases into it, and unit test case, integration testing, and you are doing automation testing. And after that, if there are any hot fixes, you have to fix those things. And there are multiple folders, you have to work on those things. Therefore maintenance become huge, because you are dealing with whole of the code in a single format, in a singular format. Therefore it is also become tedious task. Test become also difficult, as we are dealing with the whole of thing in one set. Therefore monolithic architecture is not preferred when you're dealing at a organization level. For normal projects you can use, but at organization level it is not at all recommended. And after that, we are having use of the modular structure. Why exactly we use the modular structure? First one is reusability. See, you have written some code in o.py file. It has some functions, and in that function, let's consider it is some addition, like it is calculator app, and you have written addition and subtraction in o.py file. And you want to use that function out of that o.py. You can just write import star from o.py. If you write these things right, you could able to use the addition and subtraction functions out of that particular file. This is termed as a reusability. You're writing the code once, you're using again and again. And consistency. See, any changes you make in that particular file, and it is updated in whole of the file. You make any changes in the addition function, and you make any changes in the subtraction function, you don't need to declare everywhere. You are updating that particular file, you are using those file everywhere. Therefore it is consistent. You don't need to update everywhere, it is consistent. And scalable. Okay, now you are introduced with the addition function, subtraction function. Now I want to use it for adding thousands of things in a singular format. Like for example, you are having a array is having around 10,000 of elements, and you have to add those all things. And in such case, you can able to implement it at a very large scale, because you have built a simple modules. Now you are having a function addition, you implement some things inside that. In such case, it could able to add 10,000 elements at once. And this is how we go with the scalability. And after the scalability, we are having the Terraform structure. Now we are introduced with modular structure in the Terraform. As I already discussed, so why we are using the monolithic and the microservice exactly over here. Terraform is also building a lot of things. For example, there are 10,000 development teams, like 1,000 development teams that are working on different parts of some particular application, and they require some of the resources. And see, we have written some in the modular structure for EC2. You have written some modular structure for S3. You have written some modular structure for the Lambda, CloudWatch, EKS, ECR, and code commit and the code pipeline. You have written a lot of modules for every resources of the AWS. In such condition, it become very easy for them to create EC2, because you have written it in a format of modules. They will just go to EC2 and they will request, they will run that particular file, they will get some EC2 instance. They want S3, they will get S3. Just think of it, when you write everything in one code, it become very huge and it become very headache for them, because if you have written EC2, S3 and EKS, ECR in a one file, when they tend to execute those all things, not only EC2 is created, but it is going to create S3 as well as ECR and EKS. Therefore, building a modular structure is very recommended. Then how we go with it? We have the main.tf file, the Terraform file where everything is executed. You just need to say Terraform init, Terraform plan, Terraform apply. It's going to create all of your resources. And what is variable.tf? Here already I discussed, we declare some of the variables, like this is my variable AWS instance, and this is having this default value, this is the type of that, this is a description, and in the tf fields we assign the values. And in the main.tf, when I say where.aws instance, it is gonna give me the example, like what is the name of that particular variable name. And if we want S3, we can assign the S3 variable, and we can able to do a lot of things. And after that we have the output.tf, and whenever you execute everything, you have to get an output out of it. Like you have said, okay, I want EC2 instance, you have to create it. To create that EC2 instance, once it is created, you need to know what is public IP of that, what's the private IP of that, what are the security groups, so that we can update and use it everywhere. To do those all things, you need output of that particular thing. This is done using the output.tf, and this is the modular structure of the Terraform. This is how we go with modular structure. We can able to update those things, and we can able to do those all things fine. And this is how we normally go. I will go with using practical methods. Okay, this is all about it. Thank you.